Hi everyone, I welcome you all to Azure Developer Community's great initiative of ML Marathon. This marathon is going to be a proper experience for you all to get started in your journey of machine learning from scratch, and it will help you to enhance your skills at the same time. We would be providing you a problem statement at the same time so that you can learn more and have some amazing hands-on experience for the same. So, with that note, yesterday we had our session one, our day one, in which we talked about the introduction to machine learning. We talked about some algorithms of machine learning, and today and also you have downloaded and installed Jupyter Notebook at the same time. Today we are going to proceed with some other functionalities, like we would be talking about some other things. It would be like performance matrix, clustering algorithms, hands-on project, and tree-based algorithm. So that's how our today's session is going to look like, and I hope that you all are going to learn and explore more about all these things. And apart from that, the submission deadline has been extended to 9th of October to 10th of October. So you can start working on that, and it's going to be something amazing. So, with that note, let me just share my screen first of all, so that I can just give you a glance how everything is going to look like. You can just is certificate will yes, the participation certificate will be provided to all, and the top 10 projects would be receiving Microsoft Azure merchandise and zippers at the same time, and also certificates for them. So I'm sharing my screen to show you that how it's gonna look like. So as you can see my screen, so this is like that's how your like page will look like after you would register to the ML marathon. You can scroll down and you can see the challenges, and you can see it's written the data is related to direct marketing campaigns of a financial institution. Okay, so that's how we have actually shared one data with you. You can check out the database that we have shared on the mail. It's this. You can just check out this particular data that we have shared. Like we have shared one calendar invite, and in the mail you can check out that we have shared some links. Like this is the registration link. You can check out the day one session link. Like this was our day one. After that, you can check out the GitHub repo. This is the GitHub repo. You can just scroll it down and you can check out these installation guidelines, data like hands-on project and machine learning, the Jupyter notebook. You can just have a look into it so that you can have some like proper learning thing, that how it's gonna look like. You can see that all the installation guidelines are provided to you. After that, the next link that is provided to you is dataset and problem statement. In the dataset and problem statement, you just have to click on the link and you can see that you would be directed to the drive link, which is this. Okay, what you can see that here is in this PDF that ML marathon challenge has been written. What are the guidelines, how you can proceed with it, what is the criteria, and everything is mentioned properly. And also there are few ML questions that are provided to you. And also there's the data.cv and testdata.cv, and according to the according to the proper uh, guideline, you can just get started with your ML marathon. And with that note, you can also join our Azure Developer Discord community. It's really amazing to have you all and to have some more amazing interaction over there. So, with that note, I'll be just telling you something more about it. So, yeah. So, with that, when you just click on the dashboard, you would be directed to this particular page. Okay, so here you can see that you can see that it's something shown submit idea. You have to click on the submit idea, and you can just click on the ML solution. After that, when you scroll down, it will ask for the Jupyter notebook. You can easily export your Jupyter notebook to PDF, and then you can upload that PDF of your Jupyter notebook over here. After that, when you scroll, you can see that you will be asking to upload the results.cv file, CSV file URL with the with your predictions. and then you have to tell us that what was the value that you were receiving, okay, between 0 to 1 of precision, recall, and F1 scope. And when you scroll more, you can see that we have shared few questions to understand more about your learnings and to understand how much you have understood about this whole machine learning and how the model works and the procedure and how actually data set works. So basically we also put in one question related to data set, okay, like for example, like the missing like if there is some sort of missing value, then in that case how you are going to like handle these things. So that's how we have shared the questions. And we have in the last question you have to share like you can just try that particular thing out, and also you can like make a proper PDF of the screenshots that you have taken and share and upload it over here. After that, when you scroll more, you can see that there are few instructions that is already provided in this particular PDF. You can check this out and you can understand more about these things. So don't be worried, everything is provided to you in the documents, so you don't have to worry about it. And after filling all these details, you just have to click on the submit idea and your idea would be submitted. So that's how you can easily submit your uh, submission of the ML marathon. And like this is a website. If you are having any issue, if you are coming up with any doubt, you can just click on the view more and you would be headed over to Pallavi's profile. Here you can ask her any doubt related to anything, or you have been added to the group as well. In that case, you can just DM me anytime regarding any of your doubt. If you are stuck somewhere, if you are not able to understand how to proceed, you can easily ask me. You can just DM me. I'm in the admin role. Okay. Well, the yeah, exactly. So, certificate would be provided to the people who would be submitting the project. Okay, like registering is not just one thing. So, if you will submit your project, then obviously you would be receiving a certificate that yes, you have participated in the AML marathon. But if you will come in the top 10, then obviously you would be receiving a certificate, Microsoft merchandise, Microsoft Azure merchandise, and at the same time Microsoft Azure zippers. So that's how we are going to proceed. Yeah, so again, certificate is for only those who would be submitting their project. So yeah, that's just about like how you're going to proceed and how it's going to look like. So now today we are going to cover a few things. Let me just give you a gist that what are things that we are going to cover. We are going to cover some more about like tree algorithms, and also we would be talking about some like a proper hands-on. And again, if you have any sort of doubt regarding the submission, you can just ask Pallavi in the comment section, so that we would be very like able to resolve all of your doubt. Is it important to have knowledge of Python to solve problem statement? No, actually, the basic knowledge would be great, and obviously, we would be giving a proper like hands-on experience to you right away. So don't be worried about it. So yeah, without not wasting much time, I would be very happy to welcome Pallavi. Hi, Pallavi.
Hi, Chavi.
Great. So let's just start the session. And again, like this is the day to the final day
Yeah,
where they will be able to ask their doubts and proceed with everything. So yeah, let's see how it's gonna be.
yes. So thank you, Chavi, for clarifying the doubts because I was also receiving these kind of doubts. And I hope, everyone got their doubts cleared by Chavi. And if you have any doubts, also have a group also, so you can also post their um, doubts. So with that note, I welcome you to the day 2 of marathon. And first of all, I want to thank all of you that you joined this session and find this session informative. And I was receiving very kind messages from you all that you find this session very informative. And so I appreciate your kindness. Next is we have the day 2 of marathon. So first of all, I'll be telling you like what all things we are going to cover for today. And our first topic will be performance metrics in machine learning. So this is one of the important topics that people ask you in ML interviews. Why I am focusing on ML interviews? Because yesterday I received a lot of messages from people who are in final year or in the pre-final year, and they were very much curious, like what type of questions are asked in companies and how to get into this area and all. So, first of all, I would like to answer those questions first, and because now after that you will be free from your mind, all your doubts will be cleared, and then we can move forward. So, first question was like, I mean, if you have to, if you want to prepare for the ML questions, so where to get started? So, I mean, I have provided you the GitHub link yesterday. I mean, it is also posted by Chavi on all the groups, so you can share. So this is the GitHub link of like data science works. So if I go to this repository, so if you go to this medium, so I have provided the uh, important ML questions. So if you go to this important ML questions, we have 16 or 17 questions that I mean, provided to you. To 15 questions are there. So you can go through these questions once before going to any interview or for your internship and all. So this you can check it out. Next is people were asking like, do we get any this? Do we'll be getting the recordings and the the presentation. So yes, Chavi will be providing you the presentations also, plus the links of the video recording. And next, if you are interested in knowing the particular concept, like you don't want to go through the 3 hour long video, but you are interested in knowing a particular concept or particular term, so you can watch on this channel also. So in this channel I have uploaded all the videos for you all. And I mean this. So this was the question that I was getting. Next is we are good to go to our first target, that is performance metrics in machine learning. So before starting, so let me share my screen. So yeah, so can we start? Please comment in the section performance metrics in machine learning. I am watching all your comments. Please comment a yes. So I'm waiting for your yes, and then we can get started, because I don't want, because this is one of the most important topic that is going to teach you. So most of the people are saying yes, so I am good to go. So yes, performance metrics in machine learning. So can you tell me, I mean, why do we need performance metrics? I mean, what is the use of it? So if yes, you can type in the, comments. So why do we need performance metrics? So let me explain you. For example, you will be so we explained you about hackathon idea, how to submit and all. So how do we assess the performance of these models? So many people will be submitting different kind of their solutions, their results, and everything. But how do we judge? I mean, how do we are going to judge? So based on these metrics, so one person is accuracy of the model is 80%, other person getting accuracy of 96%. So that means 96 percent model performing is good. So we'll be going towards that. So performance metrics tell you how your model is performing, how your machine learning model is performing well on the testing datasets. So let me provide you the agenda. So we have two different modules. So I have clubbed in a single one for you. So first one is regression and next one is the classification. So in the regression, let's discuss the mean squared error. So can you tell me what do I mean by error? So I have provided in the the introductory slide that I've told you yesterday about the error. So we have to focus on two things. I said that is first one is the actual, and second one, can you tell me what is the thing? Yes, so it is predicted. So actual and predicted. So you just error is the difference between the two. So mean squared error. So we'll be going, step by step, and from this name also, name only, you will be good to go to derive this formula. So error means what? Actual minus predicted. Okay, squared means what? I'm squaring it. And means mean what? We are summing it. I is equal to 1 to n, divide by n. So you know how to calculate a mean sum of the observations divided by the total number of observations. So in the name itself, it is everything is it's written. Error is basically actual minus predicted. Square, I'm squaring it. Mean, I'm taking mean of it. So in MSE, there is mean squared error. So these are the regression metrics. So we take average of what? Of the square difference between the actual and the predicted. So you already know the actual, and your model will be predicting some value, and from this, actual minus predicted, you're good to go with the error. So now I am going to explain you this with the Jupyter notebook also. So please open your Jupyter notebook. So I have opened my one. So what you can do is go to this page and search for this repositories. In repositories, you have to go to this machine learning. In machine learning, you have to open this notebook, that is performancemetrics.ipynb. This notebook, I'll tell you how to do this. So I'm giving you 1 minute time to basically go start your Jupyter notebook and this performance metrics. So if you're good to go, so I can start. So if you're not able to open this notebook, that's also fine, because I'll be explaining you on the go, hands-on. So like mean squared error, as I already told you, this is the sklearn metrics. I have from this, I have imported. So from sklearn.metrics, I have to import this. Now, my actual and predicted. So I already told you have to focus on two things. First one is the actual and next one is the predicted. So actual and predicted. And what I'm going to take, the difference between the two. So what I'm doing is, I'm just calling mean squared error, and I'm this actual and predicted I'm passing, and it give me the value of 0.685. So if I run this, so it provided me the value 0.685. So mean squared error is this. So but I want also to verify using this formula. So how, it is internally calculating. So we are doing this 3 minus 2.5 squared plus 0 minus 0.5 minus 0.2 squared, 2 minus 1 squared plus 7 minus 8 square. So this is the, we are taking the error and we are squaring it, but we also have to take the mean. Mean is the total number of observations. Total number of observations were 4, so I divided by 4. So let me divide this. So using the formula also we verified, and with this also we verified. So please type a yes if you are good to go, and if not, I'll explain again. So I'm looking at your comments now. Yes. So we are good to go, I think. So let's do the next one, the graphical way. So the green lines, as I already told you yesterday, in linear regression, these green lines are the what? These are the residuals, I can say, or these vertical lines are the distances of the data points from the line. Okay. Now comes the other one, that is RMSE. So in RMSE, it is also same, right? Mean squared error. So it is also same. And what is root? So root means I'm just taking the square root of it. that. So RMSE I can say is the square root of mean squared error. So everything will be same. Error means actual minus predicted, squared means I'm squaring it, mean means I'm taking the mean, and root means I'm taking the square. So from the name itself, you don't have to remember anything. From the name itself, on the go, you can, I mean, derive this thing. So for root mean squared also, I have the same thing for you. Like, so the same actual I have done, predicted, mean squared error. So what's the difference between okay, here also it was mean squared error, and here also it was mean squared error. So what's the difference? What I'll do, by default squared is false, I mean by default squared is true, but I have set to squared is equal to false. So this you have. So this can also be asked from you. Okay, so in Python, when you do MSC versus I mean RMSC, what's the difference of the parameter that you do? So you'll say I'll set the squared parameter to false, and then it will be root mean squared error. So same I have done using the this thing was the below one, sorry, the above one, but I have taken the square root function. So let's verify. So both the values are same, I mean, so we verified using the formula also and from the sklearn library also. Next is the mean absolute error. So in mean absolute error, let's decode again. So error means what? Actual minus predicted. Absolute means what? I'm taking the absolute value. Mean means what? I'm taking the mean. I is equal to 1 divided by n. 1 to n divide by n, because you know what do you mean, what do I mean by mean? Mean means total sum of observations divided by the number of observations. So this is mean absolute error, and you can also check that in notebook also, the mean absolute error. So I provided you the performance metrics.ipynb notebook. You can try out these values and tweak those values, change the values and see you're good to go or not. So these were the regression metrics. So if someone asks you, okay, so you have a regression problem, so can you tell me how do you evaluate the performance of a regression model? So now you can say, yes, I can do that with the help of MSC. I will calculate the RMSC. So these metrics I can calculate. So you can answer this question now. Next is the, I mean, the classification metrics. So I'm before moving to classification metrics, because this is a very important topic that will tell you about the confusion metrics along with the examples. So I'm giving you, I mean, few seconds before you type me a yes, and we can go ahead. So the classification metrics. So I mean, everybody said yes. So I'm moving forward. So first concept that I'm telling you is the confusion metrics. So the name is also confusion. So I'll try to avoid this confusion, and I hope it will not be confusing anymore after this slide. So what you have to check, as I already told you, you have to focus on the two things. What are those two things? First one is the actual, and second one is the predicted. So same thing I have written here also. So this is actual and this is predicted. Now tell me what are the possible values of actual? Actual possible values are, it can be positive also, it can be negative also, and for predicted also it can be positive and it can be negative, right? Or you can say in the Boolean algebra it can be 0 or 1. Predicted 0 or 1. Now just focus on these two things, actual and predicted, and negative and positive, positive and negative. So these two possibilities are there. Just forget about these square metrics and just forget about these values now. So you just have to focus on the two things, actual, predicted, two possibilities, positive, negative, and two possibilities, positive, negative. Now, for example, you were trying to derive this metrics, like you don't know it's true positive or false positive because the names are also confusing. So I have developed a trick for you all to decode this. So let's check this trick. Trick to remember is true or false and the predicted. Okay, so true, false, or predicted. So first you have to check is, if positive and positive both are matching, if both are matching, that means true. So I've taken as true. And what was my predicted? Positive. So I have keep it as positive. So it is true, positive. Next is positive, negative. Positive, negative, both are not matching. If both are not matching, keep it as a false. And what was my predicted? Predicted was my positive. Next, can you do me for one time? For the third one, tell me what will be the value. Negative, positive, both are not matching. So first will be false. And what was my predicted? Negative. So I've kept it as negative. And the final one now, negative, negative, both are matching. So true. And the predicted is negative. So this that is how you can, I mean, always draw confusion metrics on the go. You don't have to remember anything. You just have to focus on this trick. So if both my actual and predicted will be matching, so I'll choose the true for from this and append the predicted. And if they are not matching, I'll choose a false from this and predicted. So let's do one more time. So for this, what will be negative, positive, negative, positive, both are not matching, false. And what was my predicted? Negative. And this for this also, positive, negative, both are not matching, false. And what was my predicted? Positive. So yeah, just focus on the two things here, false positive and false negative. So false positive means what? Actual is negative but predicted is positive. False negative means actual is positive and predicted is negative. So this was about the confusion matrix. um, Initially it will be looking to you as a confusion, but using this trick I can assure you that you're good to go. So just check the values, actual and predicted. If they are matching, select true. If they are not matching, select false and choose the predicted. So if you're good to go now, because this confusion matrix is very important, from this confusion matrix only I'll be deriving all the metrics for you. Accuracy, precision, recall, F1 score, all the metrics will be derived from this confusion matrix. So I want you to comment a yes so that I can move forward. Just type a yes if you understood the confusion matrix, or otherwise I can explain again. So yes, I mean, most of them are saying yes. So yes. So this is the trick you have to remember. Actual and predicted matching, true, not matching, false, and the predicted. Okay. So now, most of you might be having doubt. Okay, so I have derived a confusion matrix. So do these things play a significant role in the real world also, like true positive, false negative, true negative? Yes. So in the past two, I mean, years, we have COVID situation. You are aware of that. So yes, these things play an important role. So TP means what? TP means person has COVID and the test also detecting him as COVID positive. Okay, so this is TP. So COVID also, that is true, and positive means the test is also detecting him as COVID positive. Next is true negative. True negative means person doesn't have COVID and the test also detected him as COVID negative. So whatever the actual person was, our model is also detecting the same. So this is good actually. True positive and true negative are the right things. So actual is also matching, and I mean predicted is also matching. So let's verify this with this. So in the case of true positive, what was my actual? Positive. Predicted also positive. So both are matching. Next is true negative. My actual was also negative, predicted also negative, so true negative. Okay. So true positive and true negative. Now I have to also told you that false positive and false negative you have to focus on. So false positive is what? Actually, it was COVID negative and predicted as COVID positive. Okay. Next is false negative. False negative means actually COVID positive and predicted as COVID negative. So now in COVID kind of applications, if someone is building COVID kind of applications, what is more important to you? Please comment. False negative, I mean, is will be more important to you. Why? Why? Because false positive is why false negative is very important to you. Why? Because if the person is COVID, if the person is having a disease, if it's COVID positive, and if it is telling, the test is telling, okay, it is not I mean COVID positive, it is COVID negative. Okay, so test is telling false. Okay, so the we don't want that, because we want that whatever person has a disease, we want them to be detected. So in COVID kind of application, if someone asks you, okay, I'm building a COVID application and I want to detect the persons who got COVID, so what is the thing, do you, I mean, what is the thing you focus on? Will you focus on false positive or false negative? So what you can recommend to them? Yes, you can recommend to them that I'll be focusing on false negative, because I want the person who is COVID positive and predicted as COVID negative. Don't want that. I mean, you have to focus on this false, reducing this error, false negative. So I'll be telling you false positive and false negative are the errors in statistics. So false positive is the type 1 error and false negative is the type 2 error. Error is why? Because the first term is false. False means they are not matching. Actual and predicted are, I mean, not matching. So you have to note this point. Next is the metrics. Now I'm going to derive one by one all the metrics from that confusion matrix in the first slide only. So let's check first the accuracy. So accuracy is what? The correct predictions divided by the total predictions. So can you comment what are the correct predictions in the confusion matrix? If you see, correct predictions mean actual also same, predicted also same. Actual and predicted both are matching. So accuracy, I can say true positive plus true negative are my correct predictions. Divide by the total number of whole, I mean this. So this is the accuracy formula. True positive plus true negative divide by true positive plus false positive plus true negative plus false negative. So you divide whole. Okay. So this is the accuracy formula. So now, if someone asks you, okay, I'm building a model. So now, does accuracy is always the best metric that you can prefer? So you can say what you are thinking. I mean, what's your idea? Does accuracy is always the good metric to get started for all the models? So your answer will be no. So accuracy is not always the good metric. Why? Because in case of imbalanced data set, also, I mean, your accuracy of the model can be higher. So accuracy will not always be the right metric. Okay. So this people ask you in interview. So if you are in final year also, so please make a note of it. Next is the precision. So precision basically is telling the correctness of your positive predictions. So in the confusion matrix, I have told you precision. So let me frame your question and then you can answer. So how many are actually positive out of the total positive predictions? How many are actually positive out of the total positive predictions? So let me go back and to this slide. How many are actually positive out of the total positive predictions? So what do I mean by positive prediction? First row correspond to positive predictions. And how many are actually positive? So you will say TP divided by TP plus FP. So you can derive the formula for, I would suggest there's nothing to remember. Okay. You just have to draw this matrix using that trick that I have defined. And one by one, you are easy to go. So in precision, you have to focus on the positive prediction. So positive predictions is the first row. So what I will go TP divide by TP plus FP. So this was my precision. So how many are actually positive out of the total positive predictions? Tell you the correctness of your positive predictions. Now, tell me, what does a high precision score signify to you? Please comment. What does a high precision score signify? So high precision score means what? So we want this precision to be higher. So what do we want? We want false positive to be lower. Okay, false positive will be less, then precision will be higher. So precision is the metric, that is focusing on the type 1 error. Type 1 error is the false positive, but what it is not focusing on, it is not taking care of any false negative. Okay, but precision is taking care of false positive. Why? Because false positive is low, then precision will move higher. So the range of also in hackathon also I have provided you. Please provide the range between 0 and 1. Okay, so maximum is your 1, high precision. So can you tell me when the precision will be 1? Yes. So for when false positive is 0, TP. So if you keep this as 0, so TP by TP. It will be cancelled and it will be as 1. So precision is 1. 100% precision you got. Okay. So 0 to 1. So if you are building a model and your model is performing from 0.6 to 0.8 precision, then you are on the right path. Your precision is improving over time. So 1 is the best, and if your model is like performing below 0.5, then you have to change the strategy and do something else to make the precision good. Yeah. So next is I'll be telling you the recall. So these are all the metrics that I have asked for you in the hackathon also, like the precision, recall, and the this F1 score. So these are now I'm explaining one by one. So in recall, how many are actually positive out of all the positives in the data set? So I want you to derive from the confusion matrix how many are actually positive out of the all the positives in the data set. It's simple. TP divided by TP plus Fn. Let's derive this with the help of this. So how many are actually positive out of all the actual positives? Now actual positive is the first column, okay? You can see actually it was positive, so first column is TP divided by TP plus Fn. So true positive divided by true positive plus false negative. So from this matrix, you can derive any kind of metric. So let me go back to recall and let me frame you a question. So recall is TP by TP plus Fn. So now can you tell me what does a high recall score signify? So in I mean high recall means when false negative will be lesser, your recall will be higher. So recall is focusing on which error? It is focusing on type 2 error, but it's not taking care of the type 1 error, which is false positive. So two things I have told you. Precision is focusing on type 1 error, which is false positive, and recall is focusing on type 2 error, which is false negative. But both are not focusing on the, either one, other one. Next is the F1 score. So we have precision and we have recall. So then they said, okay, you have precision and you have, let's combine both. So the combination is the F1 score. So F1 score is the harmonic mean of precision and the recall. So it combines both precision and recall. Harmonic mean you can easily specify. You have studied in mathematics. So 1 divided by 1 plus 1 divided by precision plus 1 divided by recall. So if you evaluate this F1 score, evaluates to 2 into precision into recall divided by precision plus recall. So this is your F1 score. So that's all about the F1 score. So these three metric precision, recall, and F1 score, I have also asked in the challenge also. So next is what does high or low F1 score signify? Can you tell me? Please type in comments. What does high or low F1 score signify? So when the F1 score is high, you can tell okay, precision and recall both have good combination. So precision and recall both are performing good. But when it is low, when F1 score is low, we cannot comment anything about either precision is low or recall is low. So this was one of the questions that I have been asked in my data science journey of interview. So I have asked like, what does high or low F1 score signify? So you can say when it's high, that means precision and recall both are good, but when it's low, we cannot comment anything about precision or recall. Either of them can be low. So, I hope F1 score is now cleared, and this marks to the end of the performance metrics in machine learning. So, you first, I'll provide you a recap. In regression, you can tell, is MSC, RMSC, and the MAE. You can, if anyone asks you what metrics you are going to use for the regression, so you can tell MSC, RMSC, and this. And for this classification, you can tell, okay, I can use accuracy also, precision also, recall also, F1 score also. And now you know the meaning and the significance of each and everything. So we have done the complete the performance metrics in machine learning. So let me go back to this. So module 4 and 5 we completed both the modules. Now come to module 6, that is the clustering algorithms. So I'm giving you a few, 1 minute. So please type a yes if we can start the unsupervised learning. So in this also, I'm going to teach you very important algorithms. First one is k-means and the second one is the hierarchical clustering. So please type a yes if we are good to go in unsupervised learning. I'm seeing your comments. Okay, so we can start unsupervised learning. So unsupervised learning, I have already explained you yesterday also. So unsupervised learning, can you provide? Can you recall? So we have unlabeled data set. First of all, we don't have the labeled data set. We have unlabeled data set, and we will be utilizing the clustering techniques to group the similar kind of data together. So that's what unsupervised learning is doing. So can you tell me what is clustering? Clustering means this is the unlabeled data. I don't know. It's a triangle, or I don't know. It's a circle. The machine don't know. We can see from our eyes, but the machine is not. Don't know. So this is unlabeled data set, and now I am. Clustering this data set into two clusters. So first of all, it is, the green data points is one cluster, and the triangles is the second cluster. So what is clustering? Clustering is the grouping of similar kind of data, same data together, similar data together. So grouping similar things together such that the objects in the same cluster. So when objects in the same cluster are more similar to each other, so they are more similar to each other than those in the other cluster. Like, so what are kind of the applications that you can say? So if someone is ask you, okay, I have a store, okay, I have a grocery store, and I want to segment my customer based on how much they are buying. Someone is inclined towards the electronic items, someone is inclined towards the shopping items. So what you can do, you can say, okay, I'll apply the I can apply the clustering techniques in the for the segmentation of customers, for dividing the customers into different groups. Like one group can be the person who likes who likes to buy electronics more, the other person who like to buy clothes more, the other person who is more inclined towards buying some other things, right? So we can apply the clustering technique. So people ask you the applications, and then they ask you which technique you are going to use, so you can tell to them that I'll be using the clustering technique. Next is the document clustering. So in document clustering, like you have a set of documents. Now these documents are some are belonging to science, some are belonging to politics, some are belonging to mathematics. Okay, so what you can do? So okay, you have a set of documents, and now you can say, hey, I want a proper format. So what you can do? Okay, so I'll apply the document clustering. Okay, so I'll group the science documents together, English documents together, and these kind of applications in the customer segmentation, you can utilize the clustering technique. Next is the k-means clustering we are going to discuss today. So k-means clustering is a very important algorithm for today. So let's discuss how, and I'll provide you the step-by-step process of doing this. So first of all, let's understand what k-means clustering. So it is an unsupervised learning, and it's an iterative algorithm that groups the unlabeled dataset into k different clusters. Okay, so it's similar. And one thing you have to keep in mind that each element will belong to only one cluster. Okay, it's not that it is belonging to this cluster also and this cluster also. No. So in k-means, you have to group the unlabeled dataset into k different clusters such that each item will belong to only one cluster. So k is predefined. What is, in k means clustering, what is k? K is the number of clusters. So you can say, hey, I want to build two clusters. Someone can ask, hey, I want to build three clusters. So k is the number of clusters. Now, let me explain you with this, the mathematical representation that I have presented here. So given a set of observations x1, x2 up to xn, you have n observations. So where each observation can be a d-dimensional real vector. So k means its k means is doing. So you have these observations. What you want, so for each observation, you will be calculating the distance of that observation from the centroid, or you can say the center of the cluster. And we want to minimize this distance because what I told you is objects or the observations in one cluster should be closer to each other than the other elements in the other clusters. Okay. So, don't get confused with this, wording on anything. I'll be explaining you each and everything for you this. So, what we are doing for all the observations x minus mu I is equal to 1 to for each number of clusters, I want to minimize the within cluster sum of squares. So this is called within cluster sum of squares. Now let's decode this algorithm step by step. This was a summary. Now I'm going to decode it, the steps. Now from these steps you are good to go. So step one is you have to choose the number of clusters. So suppose you said, okay, hey, I want to build three clusters. So what you will choose, k is equal to 3. Next is the, I will be randomly selecting three data points as centroids. So let me select it. So as you can see on the screen, this was my whole data set. And then I said, okay, for this data set, I'm choosing three clusters. Okay. So in three clusters, so I randomly selected three data points. So this data point, and this data point as centroid. So please comment like red, green, and blue are my three centroids. Centroid is, the center of the clusters. So these are randomly chosen. So first step is I selected the three because I want to select three clusters and randomly just choose. It's not necessary that it will be my this. You can choose this one also as a red, this one also as a center, this one. I have randomly selected these data points as centroids. This was my step two. Next is assign all the data points to the closest center, cluster center. So this data point will be closer to what? You have to calculate the distance of this data point to this. To every cluster, you will calculate. So say this distance is 1, this distance is 2, this distance is 3. So what you will be choosing? 1. Because you have to choose the smallest distance. Assign all the data points to the closest cluster centroid. Now for this point also, you will be calculating the distance of this data point to this cluster, to this cluster, and to this cluster, and choose the minimum out of it. After doing this repeatedly, you'll be doing this. So you'll end up assigning these points. So this data point distance was lesser to this, so I assigned to red. This data point distance was lesser to green, so I assigned to green. This is also green, also green, 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 green. Now these points are closer to blue, so assign them to the blue. So I mean, and this was the step 3. So first step, choose the number of cluster, randomly select any data point as a cluster, and after that, calculate the distance of every point to the cluster that you have chosen, cluster center that you have chosen, and whichever is minimum, assign that data point to that cluster. Okay. Please, I mean, if you have any questions in between, please feel free to ask me and stop me. I'll explain again. So if no, you can comment yes. I mean, I can move ahead. Okay. So this is a very simple step. So I have assigned the data points to the closest cluster center. Now I have said, okay, the distance of this data point to this is 1. The distance of this data point to this was 2, and this the distance of this data point to this was 3. Say I'm supposing this distances. So how do I calculate these distances of the data point to the center? So the answer is Euclidean distance. So Euclidean distance formula, you can easily calculate the distance of the data point to the cluster. Next is recompute the centroids of newly formed cluster. So this explain my step 2 again. So step 2, initially I choose 3 random data points as initially the cluster. Next step, what I did, I assigned all the data point to the closest cluster. So this was my, I mean, belonging, the distance was lesser to this, so I assigned to red. The distance was lesser to green, so I assigned to green. Next is you have to recompute the centroids of newly formed, because now um, if you see here, initially I have told this as my cluster center and this as my cluster center, but when the observations in this area increase, so your cluster center will also change. Okay. So here also you have to, so for this area you have to compute the cluster center. Now the new cluster will be this, new centroid will be this. For this data set, if you calculate the centroid, okay, so it will also move to this, right? And it will also, so you have to compute the cluster center again, because that's how the, it's an iterative and algorithm, and it will try to do that. Okay. Next is recompute the centroids of newly formed clusters. And next is we have to repeat this process again and again until convergence has been reached. So this slide provides you a complete recap of the entire k-means algorithm. First, I have chosen 3 clusters randomly, red, green, and blue. Next, I assign them to the closest cluster center, all the data points. I will compute the distance of that every data point. You have to compute the distance of that data point to the all the clusters, and whatever is smaller, assign to that. Next, I have what I have done is I have recomputed the cluster center. Why I have recomputed? Because initially I have chosen this to be cluster center, but now 2 observations are there. Now the cluster center will be changing. So I have recomputed it. And next is step 5. I will be doing this again and again, again and again until until the, I mean, number of iterations are reached, or until it makes no difference. So if someone asks you, okay, when you are going to stop this, you said okay, it's an iterative algorithm, but some criteria, some stopping criteria will be there to stop. So you can say maximum number of iterations are reached. So you can say okay, I just want to run for say 10 iterations just, so it will be stopped after 10 iterations. Or you can say the centroids of newly formed cluster do not change. And that means when you're doing this and again you're doing this, but the center of the cluster is not changing, centroid is not changing, again you're doing this, the center is not changing. So that means that is the time you have to stop, because after doing also it is not making any difference, so you just have to stop. So convergence, maximum number of iterations are reached. So you can say okay, I just want to run for 10 iterations. For example, for I is equal to 1 to n, I n can be 10. Next is centroid of newly formed clusters do not change. When you're applying these things again and again, but the cluster, the center of the cluster is not changing. That means we have to stop. And data points are remaining in the same cluster after application also. The data points are in the same cluster, so they are not changing, they are not moving to other cluster. That means you have to stop it. So that's what about the k-means algorithm. I hope, it is clear. Next, we are going to do is hierarchical clustering. So if you have any questions about k-means, please let me know in the comments, and we'll be having a 1 minute break. 1 minute break, and I'll be waiting for your comments to get started with the hierarchical clustering. Yes, so I'm seeing, can I choose four cluster? Yes, Arjun, you can always choose any number of clusters. So that I already told you, K is predefined and K is user defined. Depending on the user, it's the user. You can choose four also, five also, any number of, and those are randomly chosen. So it's not that you have to choose this point as my center cluster or this point as, no, you can choose any point as a random starting. But when you, because this is an iterative algorithm, so over the period of time it will automatically converge to the best. So I hope, Arjun, now it's clear. So yes, you can choose four clusters. So any questions regarding k-means algorithm that I explained, please write in the comment section. So I think, everybody understood, because that was very easy, with the help of that one slide. uh, that is this slide. So this slide explains the entire k means to you. So while remembering k means, just, so Arjun is asking how number of clusters affects the algorithm. So as I already said, in k means, what is the, what is, you have to specify k is the number of cluster you have to specify. And Arjun asked like how the number of cluster affects the algorithm. So what I can say is, if you say, the number of clusters are increasing, okay, so your performance will also increase at some point of time, but after some point of time your performance will decrease. So there is kind of one method that I'll tell you, that is an elbow method. So in elbow method is basically, you'll plot the graph between the number of clusters versus the variance. Okay, so variance is, you know the meaning of variance. So for example, if there is only one item in the cluster, only one data point in the one cluster, so variance will be zero. If there are some data points in the cluster, then variance will be something. But if there is only one point in the cluster, that means you have to, there is variance is zero. So regarding k, it has been observed that if you increase the number of clusters at some point of time, it will give you a good performance, variation is good. But then after that, the it will not perform good. So this kind of an elbow method. So in elbow method, you can, using the elbow method, you'll be plotting the graph between the, the number of clusters versus the variance, and the point at which it drops. So that is kind of the elbow, and that was choose for the, provide you the best cluster. So it's, say for example, k is equal to 5 is assumed to be a good uh, cluster. Okay, so k is equal to 5 is, work most of it, but you can always plot the graph and then see at the point. Okay, so this is the elbow method that you can use. So I hope, Arjun, now it's clear how the cluster affect the algorithm. Okay. So any question? Yes. So Pooja commented yes. So elbow method. Yes, Pooja. Elbow method is the, you can use it. So I hope it's clear. Now it's time to go to hierarchical clustering. So can you tell me, I mean, what is the thing that I'm moving to another clustering? Is k means not very good? Why? Because we have to specify the k. Okay, we have to specify how many clusters do I need, and that is kind of hectic. So we are moving to hierarchical clustering. So in hierarchical clustering, we are building a hierarchy of clusters. Okay. So there are two types that I'm going to tell you. First one is the agglomerative, and second one is the divisive hierarchical clustering. So agglomerative is a bottom-up approach, yeah, bottom-up approach, and divisive is a top-down. So you can assume a tree is there. So from root node to the leaf node, you are going. That is a top-down approach. Okay. Or if you are going from leaf to top, that it means it is a bottom up approach. So these two approach, but I'm not going into the most of the theory of this, but I like try to explain this with the visual diagram because it will be easy to you to get it. So you just have to things remember. In hierarchical clustering, we don't need to specify how many cluster you need. So you don't need to specify k. K is the number of clusters you don't need to specify. And two type of hierarchical clustering: agglomerative and divisive. One is top down and other is bottom up. This you have to remember. That's it. Now let's go to agglomerative. Agglomerative means it's a bottom-up approach. So, for example, you have a raw data points. You have one, two, three, four data points, and now I said, okay, I have these four data points. In real world, these can be 1,000 data points and more than that. But let's for assume this, for example, we have four data points. Okay, so what I'll do in the first step, I'll assign each to a separate cluster. So let me assign. So okay, I'll assign first data point to red cluster. Next, I assign this data point to black cluster, third data point to pink cluster, and fourth data point to white cluster. So I have the raw data and I assign every data point to a separate cluster. So initially all data points are in separate cluster. Next is in each iteration, you're going to merge the closest pair of clusters and repeat this step. So let me go back. So in each iteration, so in iteration one, I'll see, okay, they are closer to each other. So let's group them into a cluster. Next, I'll watch, okay, these are closer. Next, group them to one cluster. Next, okay, group. So at the end, we got only one cluster. Okay, because we are moving bottom up approach. So in each iteration, you have to merge closest pair of clusters and you have to repeat this process until when? Until you get a single cluster. So that's what I did is basically the first data points were closer. So I merged those clusters. Then I merged these three and then let me merge other. So at the end, you got only one cluster. So this was regarding the agglomerative. Now let's move to divisive. Divisive is what? It's a top-down cluster. It's a top-down approach. Top-down approach means we go from root to leaf. I mean, in the tree terminology, yeah, it's better to understand that. So in divisive, we start with a single cluster. So let's start with a single cluster. Next, in each iteration, what you're going to do, you're going to separate the point data. In each iteration, the data points that are not similar, okay, that are not similar are separated from the cluster. So the separated data points are treated as an individual cluster. So at the end, you will be getting multiple clusters. You start from single one and then you in each iteration, the data points that are not similar, just remove them from the cluster. So that's all about the hierarchical clustering. So we understood the two main algorithms that are being asked in the unsupervised learning. First one is the k-means and second one is the hierarchical along with the visual representations. So I hope it's clear to you all. So before moving to the, I mean, let me check. So we have only one module pending, that is tree-based algorithms and the hands-on project we have. So what do you want first? So first you want a hands-on project or the tree-based algorithms? Please mention in the comments. Whatever you will tell me, I'll go with that. So in tree-based algorithms, we'll be learning the decision tree and the random forest. And in the, um, the hands-on project, we'll be going through the herd disease classification. We'll be doing the hands-on. So one person is saying hands-on and one person is saying tree. So please, guys, comment more so that I can. Okay, so most of the them are saying the tree-based algorithms. Okay, so what I can think is, tree-based algorithms is a kind of it will take 20 minutes, and then we can start with the hands-on also, because I have with me the hands-on project for you. So this is my project hands on. This is the herd disease classification. I'll tell you how to develop the notebook from scratch, and how to I mean specify each and everything, along with the data visualization, getting predictions, confusion metrics, everything we are doing. Okay. And so here I'm trying the random forest also, which is kind of one tree algorithm. So I want you to know before, like, what is the random forest, and then you can easily say, okay. So Ashwin is saying hands on, someone is saying tree based, so I'm confused. So more people can comment maybe to help me decide. Okay, so let's go with the algorithm first, and then I'll give you the hands-on on this. And in the meantime, if someone has not downloaded the the Jupyter notebook and everything for this classification, so let me go back and first tell you. So this is the machine learning. So you go to this repository, Data Science Works, and here I have provided the hands-on project. So here you have to just click on this code and download as zip, and then you're good to go. Because I want you people also to, run this on the go. And this will also provide you a gist like of how to submit the project for tomorrow hackathon, and what I'm expecting from you is. So in the meantime, if someone has not downloaded, you can prepare. Yes, Gurpreet, you can prepare for laptop, and so please everyone be ready with this notebook in the meantime, and I can explain you the tree-based algorithm first, and then we'll be trying each and every algorithm that I explained you today in the hands-on, so that it will be easy for you to track why I'm transitioning to a particular algorithm. So this is my decision tree and random forest. So this is also the important topic for today, and that is decision tree and random forest. And I've given you the ML questions also for the hackathon. So please be ready for this topic, and because many of you will be able to use this algorithm. So let's get started with me. What is a tree decision tree? So it is basically a supervised learning algorithm. So supervised learning algorithm basically means you have the label data, you have the labels with you. Next is it works like a flow chart, a tree-like structure. So tree-like structure means you have a root and you have different tree-like structure. Next is the tree-like structure makes it simple to understand the decision-making process. So, this is the theory, but I will explain you with the help of an real example. So, first, let's discuss the structure of decision tree. So, can you comment in the tree what will be my first topic that I'm going to tell you? Yeah, it's the root node. So the root node is present at the beginning of the decision tree. From root, you will start splitting the data set into one node. Then again, you will going to split according to the features. Next is the decision node. After splitting the root node, for example, there's a single root node, and you're going to split it, and you will be getting the decision nodes. Next is the leaf nodes. Leaf nodes are the end nodes where further splitting is not possible. So yes, Pooja commented right. So we have to do root nodes and leaf nodes, and one um, point is like decision node. Okay. Next is let's understand with this help of an example. So now you understood, okay, it's a supervised learning algorithm and it's follow a tree-like structure. But where do I use decision tree? So decision tree you basically use in your real life also every day while making a decision. So for example, someone said, okay, should I buy a car? So this is one of the decision. So you can say, okay, I want to buy a car, so which algorithm do you recommend me? Okay, so you can say, okay, you are in a dilemma, you have to make a decision, so let's go with the decision tree. So let's build a decision tree out of this application. So should I buy a car? So what are the possibilities? Should I buy a car? I can buy, yes or no. So if yes, that means I have one decision. Do I have a public transport reachability nearby? No. Should I buy a car? So two possibilities are there, yes or no. So if yes, that means I have to choose. Do I have a transport nearby, or do I need to travel frequently? So say if you have a public transport nearby, then don't buy because you can travel through public transport. Else you don't have a public transport, that means you have to buy it because it will be very far for you. Next is, do you need to travel frequently? You need to travel so frequently, then yes, you can buy. And no, don't buy. So this is the kind of decision tree. So I mean, this is one of the application, I mean, I can say is basically. Next is this is one of the example that people, I mean, tell you in the decision trees and all. So, for example, let's me present you with the help of an data set. So, for example, weather, temperature, humidity, wind, and play. So you have a data set, and someone is saying, okay, the weather is sunny and the temperature is hot, high humidity, and the wind is weak. Can I play tennis or not? So it's saying, no, you don't have to play tennis. Next is the weather is cloudy, temperature is hot, humidity is high, wind is weak. Can I play tennis? Yes, you can play tennis. So you have, I mean, data set depending on the weather, temperature, wind, humidity, and your deciding factor is play, whether you have to play or not. So just, I mean, draw a decision tree out of it. So how? For example, there's a weather can be sunny or cloudy. Why? Because in weather I have two options, sunny or cloudy. So my first is weather can be sunny or cloudy. After my weather is sunny, let's check about the humidity. Humidity can be high or normal. So if it's high, no, don't play. If it's normal, play. And if it's cloudy, play. So this is the decision tree that you can build out of the previous data set. You can simply build it. So if you have presented with such kind of problem, you can easily build a decision tree out of it. Now let me ask you some questions. So how do you know what will be the root node? Okay, I draw a decision tree here, but how do I know from this data set that whether will be my root node? Someone can ask, does temperature can be the root node, or humidity can also be the root node, or wind can also be the root node? So how do you decide that weather will be the root node and next node will be humidity, and next if I split, which will be my node? So can you answer, how do you know what will be the root node? Please answer in comments, I am seeing. So how do you know what will be the root node? Anyone? And next is what should be the decision node. Decision node is what will be my decision node is decision node is humidity here. This is my root node and this is my decision node. So how do you know whether is the root node and humidity is the decision node? Yes, you have to calculate the entropy. So someone commented, so we have to calculate the entropy. So using entropy, you can easily find out what will be my root node. So when should we stop splitting? When should we stop splitting? So these are some of the questions people ask you. So how do you know what will be my root node? What should be my decision node? When should we stop splitting? So you'll be using the entropy. So entropy is basically a measure of disorder. So formula of entropy is minus p log p plus 1 minus p of log of 1 minus p. So this is the formula for entropy. And entropy is measure of a disorder. Okay. So it might look odd to you. So let me explain you with this what is the entropy. So say total observations is 15, and so you have 15 people with you, and 10 people are saying okay, I drink milk, and five people are saying I'm not drinking milk. So you have 15 people. Out of 15 people, 10 are drinking milk and 5 are not drinking milk. So how do you calculate the entropy of it? So 10 are total, how many people? 15. So 15, 10 are drinking milk, so 10. So what's the probability? 10 by 15 log of 10 by 15 plus 5 people who don't drink milk. So 1 minus p also you do. 1 minus 10 by 15 is 5 by 15 and log of 1 minus p, which is 5 by 15. So that's how you can calculate the entropy. For, if you are presented with some kind of data, say, hey, I have 15 people with me, and 10 people drink milk and 5 people don't drink milk. So can you tell me how to calculate entropy? So you can say yes, I can calculate entropy using minus p log p plus 1 minus p log 1 minus of p. So next is the why do we need entropy? Why I'm calculating this? Why I'm taking the log? What is the need? So our goal is to find the best column to split on when building a decision tree. Lower the entropy, better the split. So, and, for example, if someone gave you this data, okay, and you don't know what will be my root node, where to start, uh, what will be my best column, because if you do, so someone can build weather as a root node, someone can build humidity as a root node. So what's the standard procedure? What's the procedure to do that? So you will be saying okay, I'll first calculate the entropy of every column, and wherever entropy is lower, I'll be choosing this as my root node. So better, lower the entropy, better the split, because entropy is disorder and we want less disorder. Okay. So for that example, we will be calculating the entropy of every attribute. Whether I will calculate humidity, I will calculate wind, I calculate temperature, I calculate. And the attribute having maximum information gain will be considered as the root node. Okay. So now you might be confused what is information gain. So information gain also I'll be explaining you in the next slide. There's a formula. So let me go for the one iteration of values of weather. So for example, I am calculating the entropy of weather. So what are the values of weather? Can you tell me from the data set? Sunny and cloudy was my values. So this was my data set. So for weather, what are the possible values? Sunny is a one value, cloudy is a one value. So that's what I have written here. Values of weather is sunny and cloudy. So now entropy of whole data set. Entropy of whole data set, you can say we have three play. yes and 2 no play. We cannot play from this data set. So entropy of whole data set you can calculate minus 3 by total 3 plus 2 5 log of 3 5 minus 2 by 5 of log of 2 of 5. So this you can calculate for the whole data set. Next is entropy of Sunny. Sunny you can calculate one yes and two no. One yes and two no. What I'm saying about this is play. Okay. For Sunny, just go to Sunny row. This row. What are my things for Sunny? One is a no, two no's. For Sunny, two no and one yes. So two no and one yes. So what you'll do minus one by two, one plus two, one three, minus two by three. So individual observation divided by total of number of observation. You take a log of it, and that's how you calculate the entropy. Yes, Pooja, entropy is basically the kind of disorder. So, yes. So, next is entropy of cloudy. You'll calculate. So, what I'm saying, the idea is you'll be calculating the entropy of every attribute in your data set, and whatever entropy is lower, you're going to choose that as your split, next split. So, next is the information gain. So, information gain is basically you can calculate for a particular, I mean, data set divide I mean for weather how you calculate, you calculate the entropy of the whole data set minus this 3 by 5 into entropy of Sunny minus 2 by 5 into entropy of cloudy. Now you will be calculating the gain of all the three attributes. First you will calculate the gain of temperature, next you calculate the gain of humidity and the wind. Whatever value is maximum for the information gain, information gain is how much information I'm getting by doing this split, and the maximum information you are gaining, that means that split is better. So you might be confusing, okay, this information gain is, this is a simple formula, so don't get confused by the equation that I have written. Just you have to um, keep two things in mind. First one is the I'll be calculating the entropy of every column in the data set, and what wherever my entropy will be lower, I'll be choosing that as the call for the split. So that's all about the information gain. So 3 by 5. So 3 is the number of possible values for Sunny was 3, and total 5 is the cardinality of the whole data set. Similarly, 2 is the other number of possible values for the cloudy, and 5 is the, I mean, this total number of cardinality of the whole data set, and then you'll calculate the gain of all the three attributes. So let's check the formula of information gain. So you don't manually have to do all these things calculating the gain. What I'm telling you is the decision tree working, how it is working. Okay, so you are building a decision tree, I mean the algorithm that you're trying to build. But how do you know the working? You have to just focus on the entropy, and you know the entropy formula is very simple: minus p log p plus minus p log p minus 1 minus p of log 1 minus p. So this is the formula. So this is the information gain of a particular feature in the dataset is the entropy of the whole dataset minus sigma, that is summation of value into entropy of that value. Now value is what? You have to cardinality of the whole dataset, I mean of that particular values and the cardinality of the whole dataset. Example, v is basically the feature values. For example, feature can be a sunny, can be a cloudy, right? And divided by the total number of observations. So that's what about the information gain. So if you have any questions regarding this decision trees, you can ask me. Otherwise, we are good to go to random forest. So please type yes if we are good to go to random forest. So in decision tree, you just have to focus on people will be giving you some questions, and you have to just tell them that entropy is the. Why do we need entropy? Because we need to find the best column to split on building a decision tree, and lower the entropy, better the split. So many of you are, yes, because you don't have to manually do all these calculations. This is the behind working. And the only thing you might be aware of, you need to get aware of is the entropy. And entropy, you all know. So that's all about the decision tree. So now tell me about the random forest. So forest in general, what it means. Forest is basically the collection of trees. Okay. So in forest you have multiple trees. So in random forest, in machine learning thing, in random forest we are going to build multiple decision trees. Okay. So random forest. So first of all, what is ensemble learning? So in ensemble learning, can you explain me what is ensemble learning? So ensemble means what? Ensemble random forest is a version of ensemble learning. So ensemble learning is when you take multiple algorithms or the same algorithm multiple times and put them together to make something more powerful than the original. So ensemble learning is saying, okay, when you're taking multiple algorithms, okay, one algorithm, second, third, fourth, or the same algorithm multiple times and put them together. So in random forest, we are saying, okay, I'm not just focusing on just one algorithm, but I'm taking multiple algorithms and clubbing them to make a solution that works more better. Okay, so in random forest, you have multiple decision trees. Is a decision tree is one of the algorithm that we have studied. So random forest is, that we have. Now let's discuss about the random forest algorithm. So what you need to do in random forest algorithm, we just pick, the random R data points from the training set. Okay, and we are going to build a decision tree. Okay, decision tree, we know how to build it. You have to keep on splitting the data set and from the features based on the lower entropy. Lower the entropy, better the split. And you have to choose the number of trees, how many trees you want to build. And if for a new data point, make each one of your trees predict the value of your independent dependent variable and then assign based on the maximum voting. So in regression, if you're using the random forest for regression, so that means you can average the value of all the, i mean decision tree outputs. And otherwise, if you are in using it for classification, that means we use the maximum voting kind of strategy. So in random forest algorithm, what I'm trying to say is you have a data set. Let's assume you have a data set, okay, and then you take some rows of data sets and some features, okay, some features. So one question might be, okay, do we have to the decision tree that we are making, do we have to take every column? No, because then there will be no meaning in that. So what we'll be doing, we'll be selecting the features and some random data points, some random rows. So say you have 10, you have 100 rows of data set, and then you sell and 5 columns. So you select, okay, 2 columns I selected first and 10 rows. Then I selected some other uh, columns and some rows, and you built a decision tree. And if you are building a decision tree, and the decision tree output is going to be your value according to maximum voting. So let's understand with this help of an example. You have a data set, and you have a data set, and then you split the data set. Not actually splitting, you randomly selected the some records from the data set, and you build one tree. So person A build one tree, next you again build some other tree. So these 4 decision trees you made. So internally, random forest is consisting of the decision trees. And now this so suppose you have to classify this person, or will do a loan default or not. Okay, loan default or not. So this tree is saying it will do, this tree is saying yes, it will do a loan default. This person is also saying this will also do a loan default, and this decision tree is saying no, this person will not do loan default. So we have 3 yes and 1 no. So what will be my final prediction? My final prediction will be yes. So the final prediction works on the maximum voting. Like I also selected now random forest versus hands-on I did, right? So uh, I said, okay, let me ask you first of all what I need to do. I do random forest or hands on. So, most of maximum voting, based on the maximum voting, I selected random forest to be the topic that I need to teach you first. So, that's how about random forest and I mean is also doing. So, it is building multiple decision trees from the features and the records, and you have to keep in mind that these features will not be every features in the dataset. You are selecting a subset of features and subset of rows out of it and building a decision tree and take the maximum voting. So this person is saying okay, do a hands on, this person is saying okay, do a hands on, this person is saying okay, do a hands on, and this person is saying no, first teach us tree. So what I'll select, I'll select the hands on first. So this is the real example that we also did now only. So that's all about decision, I mean random forest. So that's all about the random forest summary. So if someone asks you what do I mean by random forest, so you can say okay, random forest is an ensemble learning, and it internally build multiple decision trees, and based on the maximum voting strategy it finally classifies the result in case of classification. And in case of regression, what will be my output? My output is basically a real number, so I'll average those values. So for example, house price it is predicting, or age, or salary it is predicting. So salary it is predicting is 10,000, 20,000, 30,000, 40,000. So I'll take the average of all these observations in kind of in case of regression, and I'll take the maximum voting in case of classification. So that's all about the random forest and the tree based algorithms. We completed it in so much less time. And if you have any question, please do let me know in the comment section for the random forest and decision trees. If no, we'll be starting the hands-on project within after 7 minutes at 1:40, because I need to drink some water also. So in the meantime, in those 7 minutes, please keep your notebook ready for you. Heart disease classification. Now I'm going to tell you step by step how to apply algorithm, how to visualize, and how to keep track of everything. Okay. So I'll be back in 5 to 7 minutes. I'm going to drink some water and keep my laptop also charging. So see you in at 1:40. So I hope you have already, downloaded this Jupyter notebook in your, laptops. So I was reading all the comments in the break. So thank you all if you find this session informative. So, are we good to go? Please comment yes, or if you have any difficulty in while setting up this project, so let me know because I'll be explaining you step by step how to do start with a project from the scratch. So I'm on the and I have added the data set also. Like I forgot to add the data set, but recently I have added. So yes, Mansi Singh. So yes, I have added the data set. You can check it now if it's available or not. Okay, so we can start this. So I'm sharing my screen. So 1 minute. Yeah. So I'm sharing my screen. So I hope my screen is visible to you now. So this is the project and this is the heart disease classification that we are going to do, and all the learnings that we did in the past 2 days, like we learned logistic regression, we learned the random forest, decision trees, all these algorithms we are going to apply today. So let's discuss the data set first. So it is regarding the heart disease classification. So we will be utilizing the heart disease classification data set to predict which patients are most likely to suffer from a heart disease in the near future using the features given. So first, when you are getting started with a data set, so first you have to focus on the input features. What is my input features, and what features I have to focus on. So first of all, starting with a particular problem, you should know what is the goal of my problem. So the goal of the problem is I have to predict which patients are most likely to suffer from a heart disease. So what's my target, what's my goal? I have to predict so it will suffer or not. So first, from this statement only, I can say it is a classification algorithm. So I have to apply the classification technique because the target variable is a binary. So it will have a heart disease or it will not have a heart disease. Next, we have to understand the data set. One by one feature we will go through, and we will see what each feature means to us. So for example, age is one of the feature, the gender, the chest pain, resting blood pressure, cholesterol, blood sugar. So these are some of the features that we have. And finally, what's the target? So using the target, you can specify. I told you yesterday also, using the target only, you can say whether it is a classification, thing, or it is a regression thing. So what you can say, this is a classification or a regression problem. Please comment. I'm seeing your comments. So it's a classification or regression problem. Why? Because my target variable is a boolean one, yes or no. So it's a classification algorithm. I'm seeing your comments. So yes, so it's a classification algorithm. So in the classification algorithm, I'm going to my notebook that I've opened here. So this is the attribute information, this is the target. So this is how you start. You tell if someone else is also using your notebook, so they know, okay, what's my target, what's my attribute, each attribute means, and what I'm trying to predict, what's my goal. Okay, these are your input process. I'm going to do in the next slide, and what's my output. So first of all, let me import my libraries. So I have told you yesterday also, if you're doing hands-on now, you might get some error of these libraries like NumPy, Pandas, or Matplotlib and Seaborn. So please make sure, like, please install these libraries. I have provided you the installation guideline also. So let me duplicate it. So installation guidelines. So I have, so you have to install this pip install pandas and all these libraries before running this. And if you run into any issues, can you, explain, can tell me. So you have to import the libraries. I'm importing the libraries and I'm running the notebook now. So this was just for my this. So in this heart disease classification, you just type cd. So it will type your cd wherever your data set is. So I hope it will be in the download section only, because you now only downloaded it. So now just copy this and replace it with here. Might be your folder, wherever. Just replace and do this. So first, let's read the data first. So I'm reading the data sets and I'm printing the head of it. So head will print the first 5 rows for you. But say if you want to print the 10 rows, so you can just pass 10 here. So it will print me 10. Or you are interested in 4 only, so it will print 4 only. So let's print for 4. Or let's say let's print for 10. So for 863 for gender 1 and CP, and these are all my features, and the target is 1. So it will have the possibility of a heart disease. So these are my kind of patients. So now let's check the data first. What I can check is, I'm checking the df.shape. Okay, so I have 303 patients and I have 14 columns. Okay, I have 303 patients with me in the dataset and 14 columns that define. Columns are my features and 303 are my rows. So this is the DF. So if you simply print DF, it will also show you. So let me print DF. So it will saying 303 rows and 14 columns. And but if you want this df dot shape, you can simply calculate it using the df dot shape function, which explain the first parameter is the number of rows and 14 is the number of columns. Next is, let's check the data. So for example, the target variable is whether the individual is suffering from data set, from the heart disease or not. So 1, yes, it is suffering. 0, it is not suffering. So what I'm doing is I'm taking the df target variable. I'm using the value counts. So count is equal to df, and let me print the count. So what you can see is 165 patients are, in the data set, can have a heart disease, and 138 patient don't have a heart disease. Okay, from this. So value dot counts is a function that I have applied to the target variable. Now value counts you can apply to any of the variable. So in the feature, so count, say for example, you want to count how many person have the cholesterol that is, higher. So what you can do, count cholesterol is some simple variable, and df, I will just check this dot value underscore counts. Okay, you just have to do this. So it will automatically print you the count cholesterol for this. So that means you have multiple values, like 6 also. um, because in the cholesterol there are multiple values that are possible. Okay, but in the target only 2 values were there, so 0 1. So value dot underscore counts will be the good function when the values are less, because you can easily visualize that. But you can apply value dot counts to help understand the data set. Next is, okay, I understood 165 patients suffer from heart disease and 138 patients don't suffer from heart disease. That means, okay, so let's visualize this. So what I'm doing is count dot plot. So I have these counts with me. I'm just using the count dot plot. Kind is equals to bar. So let me do it. Count dot plot. You can also do kind is equal to bar. So bar means this is going to be a bar plot. So bar plot, it is showing. So from this diagram, what information I can get? I can get Okay, 165 patients suffer from a heart disease and 138 patients don't suffer from a heart disease. So you have to write below this. uh, you have to write this information that you do, and you can make it markdown by going on to click this code and make it as markdown. So I say 165 patients uh, have heart disease, okay, and 135 patients, 138 I think, right? 138 patients don't have heart disease, okay. So, what I'm trying to focus on this, whatever information you are trying to get from the data set and whatever information you did from the EDA means exploratory data analysis, you are telling me that, okay, I draw this graph, but I got this information from this graph, right? Because there is no meaning that you're drawing, keep on drawing graphs and you don't extract any information. So, from this graph, what information I can extract? This. So 165 patient have heart disease and 138 patient don't have heart disease. So this information. So people are only interested in the conclusion, in the information that you are getting from this data set to help know the data set better. I'm not interested in this type of graph, but I'm interested in um, this thing. Okay, so when I see your notebook, I'll see, okay, 165 patient have heart disease and 138 patient don't have heart disease. So try to explain as much as possible. Now what else I can explain from this data set? Okay, some people are having heart disease and some people are not having heart disease, but let's check how many of them are female and how many of them are male. So maybe it's that female male are getting more a heart disease or female are getting less heart disease. So is there any correlation? Is there anything? Let's find out. So what I'll do, I just have to do this df dot target. Target is my the target variable. So wherever it is 0, so that means no disease, and 1 disease. So this is kind of thing. So this I have explained to you. Next is, let's check the this male and female, how many number of males and how many number of females. Okay, so 0 is equal to female and 1 is equal to male. So let's check. So what information I can get from this graph is, you can check from this also, df gender dot value underscore counts. So you infer this information from this plot. So 96 are female patients and 207 are my male patients. So this information I'm interested in. Okay, I have a data set. So is my data set, some kind of thing like only two females are there and 100, everything was male. Okay, the data set is related to, okay, I have 303 rows and I have 302 column as a male data set, and only one row is of female data set. That means you have, your data set is not balanced data set. Your data set is unbalanced. Why? Because it is containing only one kind of people. Okay, categories in the target variable you can also see. So for example, if your target variable, if every person is having heart disease only in the data set that you're training on the model, so that means whatever value you will give in the testing data set, it will always predict, yes, it will have heart disease even though it is not. So that I'm trying to do. Let's focus on the target variable and all the other features one by one to extract information like that. So 96 are female patients and 207 are male patients. Okay, and if it like when it be unbalanced data set? Unbalanced data set, like 1% don't have heart disease and 302% have heart disease. So that means it is a class imbalance kind of thing. So but we don't have here. Next is, let's apply machine learning techniques now. So I already told you that it is a, and you also told me that it is a classification technique. So what algorithm you can tell to me? So I can apply logistic regression first because we studied logistic regression. So yesterday, just apply this from sklearn.linear model, import logistic regression. Okay, and I am importing the train test split. So train test split, why I mean importing, why I'm splitting the data set into train and test. So this is one of the thing. You have your data set, you are going to split your data set into train and test so that you can test, because for test data also you will be having the actual values. Okay, and now you can compare those values from your model predictions, and then you can say, okay, I have this actual value as this and my predicted model this, and now I can compare to get the metric values. So that's why we are doing that. Next is let me in the X. So what can you tell me what are going to be my features from age to this THAL variable? All are going to be my feature, these 13 features, and this target is my variable that I want to predict. So this is my Y and this is my X. X means X1, X2, X3. These are all my features that are contributing to the target variable. So what I've done, X is equal to these all values and Y is my 13th column, because in Python index start from 0, so it will be 13. So let's print X then. So sorry, I have to first run this. So X is my 6313. So this is belonging to one patient. Next is belonging to other patient, and so on. So can you tell me the X dot shape? I'm sorry, this is the, I mean the array. So can you tell me the Y? What will Y will look like? Y will look like, Y will contain only the target values. So for one, the person have a heart disease. For second row, the person have a heart disease, and for third person also having heart disease, and for this person, it will not have a heart disease. So one belong to heart disease and zero belong to this. So these are kind of values I did. Next is just initialize the model. I mean, and then you have to split it, and you just have to fit on the training data. Okay, X train and Y train. So you have fitted it. So let me tell in the uh, comment. Uh, I mean, you all are following, right? So let me tell in the comments. Can we? Are we good to go for the get predictions? Because you are running with me only. Can I move forward to get the predictions, because I trained my logistic regression model? So lr dot fit X train Y train. So Mansi, Suraj, Gurpreet, Harish, have you tried this? df.ilock. So yes, so what you have to do, you have your this data set, okay, and now you have to pass this, you have to train your model on this data set. So what you are going to do, you want some values. Okay, so this X is I mean let me copy this and explain to you here. Yeah. So df.ilock function is a function. So first understand this. What do I mean by this? So this is an index. This dot in the index means take all the rows. Okay. So first column in means take all the rows. So all the rows means 3030 row will be taken. Now next is in the columns. So in the columns, I have to take all the columns in the features. No, because last column is my target variable. That is not my feature. Okay. So I'm saying take the all columns, but don't take the last column. Okay. -1 means don't take the last column. So I'll explain again. So you have to index. Okay. So take all the rows means take do a column. This will take all the rows, but from the columns take all the columns, but don't take the last column. So if you are not taking the last column, that means how many value will be there. So in the what are my features? You have to take the features up to this, because this is my target variable. This is my Y that I'm trying to predict. This is not my coming to X. Okay. So these I'm taking from all the columns -1 column. So if it's -1 column, that means up to THAL you will get values. So okay, where it is, yeah. Okay, so you understood now this dot values I'm saying. iloc, so there is one function also, lock also, and iloc also, that is I mean indexed. Okay, so if you print x, then you'll be getting this. So 63 130 up to 1, but you're not getting the last variable. So I hope, Suraj, now you are fine. Now you understood what this donation notation means. Indexed, colon, colon, make a minus one. Why I'm did. So can you explain me? Okay, let me tell you one thing. So can you tell me if I say okay, x1 is equal to df dot I log of take only three rows. What does that mean? Next one, what will be my value? Because I have not specified columns, so it will take all the columns, right? But it will take the rows from third. So third, from third it is taking all the rows from the third index. It is taking all the rows. So if I say take 3 rows to 10 rows, what it will do? It will print from 3 to 9, because in Python index work from 0 to this, from 3 till end, and 3 to 10 you can do this using iloc, and it is taking all the columns. But if I say okay, don't take the last 3 columns, so I'll take all the columns minus 3, but it will print till slow. It will print till slow. Or you can say here also, like from in the column, take from third column to fifth column. So third column is my 0 1 2 3 to fifth column. So this it will print. So 3 to 10, 3 to 10 mean take the index rows from 3 to 10, and 3 to 5 means these two columns, 3 and 4, because 5 will not be included. I hope, I mean, you can easily play with this iloc function. It works according to index, so it will take the, I mean, from third index to 10 rows, and um, 3 to 5 columns. So first will be rows, and second will be column. So you can play these values around. Okay, and if you still have any doubt, please let me know in the comments. So yes, Suraj commented, right? From 3 till end, yes, and Mansi also commented, yes. Okay, so yes, we did logistic regression, and now let's get the prediction. So I predicted using this matrix. So next is so for the first customer, for the first I mean patient, it will not have a heart disease, and one it will have a heart disease. For one, it will have a heart disease. Next is a confusion matrix. Why I'm doing confusion matrix? Because I want to know how my model is performing, how much my model is performing, how good my model is performing. So in the confusion matrix, you can basically I have told you what are the 4 rows. Please comment in the comment section. What are the 4 parameters in the confusion matrix? First, it is true positive, false positive, true negative, false negative. Okay, so let me draw confusion matrix. So this is my what? True positive. This is my what? Please comment. False positive. This is my false negative. This is my true negative. So what is the accuracy? How to calculate the accuracy from this confusion matrix? So take these row, because these are actual also same, actual also same, predicted also same. 22 plus 30 divided by whole. So that's why how I calculated the accuracy. You can always calculate the accuracy using the predefined formula, but I have explained you the performance metrics in machine learning today. So I thought to calculate using the formula. So 22 plus 30 divided by whole. 22 plus 5 plus 4 plus 30. Okay. So you'll be calculating the accuracy, and your accuracy is 85.24 for logistic regression. Now, okay, I got well, good accuracy. So let's move forward and try decision tree now, because we have studied now decision tree. Let's try decision tree. So you can easily do this from sklearn.tree. You have to import the decision tree classifier. First you have to initialize, and you have to fit on the train and white train. And accuracy on what, testing you will do on what? Testing accuracy you'll don't do on the testing data set, because you have splitted the data set into train and test, and then you are doing this. So let me guess. So decision tree is giving me 77.05% accuracy. So okay, so who is performing good? I mean, confusion metrics, who is performing good? Logistic or decision tree? Now logistic regression is performing good till now for this. Now I have explained random forest also. So in random forest is what? It is a collection of decision trees. So it will be internally building many decision trees. Okay. And it will take the mac voting from every tree. So suppose it build four trees. So random forest will say, okay, four trees, tell me your predictions. So four trees will tell the predictions. First tree will tell some prediction. First tree will say, okay, the a patient have heart disease. Second, the patient have heart disease. Third, the patient have heart disease. And fourth is saying no, the patient don't have heart disease. So that means the for that person, the person will be having heart disease, because three I get yes and one I get no. So I'll be moving towards the I'll be going towards the, the maximum strategy, maximum voting. So let's do try random forest also. So in the random forest, you got the 85.25 accuracy. So in logistic regression, which are pretty much close, I think 85.24 and 85.25 are not make any difference. But random forest will be using random forest from the above algorithms. So congratulations, you completed your first hands-on project with the heart disease classification. And this you notebook you can do and do a tweak, and you can also try multiple other algorithms. And you can also submit this project in the your GitHub, and show to people that you know all these algorithms. And that's all about this thing. So let me know if you have any doubt regarding the first hands-on project that we did today. So I am looking at your comments now. Please, guys, comments. Yes, so Harish is asking logistic and random forest give same accuracy. Which algorithm is best? So I already told you in the performance metrics that it is not necessary that accuracy will might be a good metric, but for the first hands-on project I just wanted to tell you. Okay, so what will be what we have to do? You can calculate precision also, you can calculate recall also, and then compare. Maybe precision for logistic is low and precision for random forest will be good. Okay, so and in the heart disease classification, what is more important to you? A person having a heart disease is also having, being detected. So we want to our recall to be higher. Why? Because it is focusing on the type 2 error. Okay, so that's wow. So Suraj, you have to, sorry, Harish, you have to just calculate a few more metrics: precision and recall and F1 score. Just calculate for both the algorithms, and then compare. Keep on comparing. And what your target goal is, that the person having a heart disease must also be detected, like in the that also COVID kind of application. We will be focusing more on the false negative. I hope, Harish, now it's clear. Please comment a yes if you are good to go. And okay, Suraj is asking, please explain the parameters of random forest constructor. Okay, so random forest is an algorithm. So I told you like the number of it built a number of decision trees within that. So what you can do is you have to define how many number of trees you want to build. Okay, this is one of the parameters, Suraj. Like number of trees, for example, you're saying, okay, I want to just build 5 trees or 6 trees. Next is you can also say I can think of is the depth of the tree. So it is building some of the trees in the, but you want to control the depth also of the tree. So this is also the one of the um, parameter. And some of the parameters, like you want to do parallelization, or and I mean number of jobs means how many, I mean parallelly jobs can run. So that is also one of the parameter. Okay, so three parameters we discuss. Next is the I mean I can think of is I have utilized is the score. So OOB score. Okay, so that also you can specify, that is the cross validation we do. One out, one leave, one out cross validation technique we use. So these are some kind of, because random forest has many number of parameters. So what we discuss is number of trees we can calculate, sorry, define, maximum depth we can define, number of jobs that we can define, and also we can define the cross validation score and multiple parameters. So I hope, Suraj, these I mean it's enough. Next is Pooja is asking how to decide the number of trees. Okay, so how to decide the number of trees, this is a very good question. So there's a one concept called hyperparameter tuning. So in hyperparameter tuning, what we do is basically we have number of parameters, like I explained in the for the random forest I explained. So you have multiple values possible in the particular range, so you can apply multiple search techniques. Okay, so let me apply grid search or grid search CV. Yeah, okay, so these kind of hyperparameter tuning you can also apply. Also, you can do this all this task with the help of an auto ML library. So if you want to learn I mean more about the auto ML library, so you can utilize this on this YouTube channel. I have already explained you. So this is a YouTube channel that that explains all the videos regarding the hypothesis testing, SVM, central limit theorem, that people ask in interviews. So this is the, I mean, Pooja, you can refer to this auto ML slide to utilize the auto sklearn library to find the best algorithm and the best values for your thing. So we will be deciding the number of trees using the hyperparameter tuning technique, using some of the search techniques for the different parameters. So yes, any question? Because we now have a question session now. Please feel free to ask question about anything. Yeah. So, and if you want, because if you don't want to go through a complete session of the videos that we will be sharing with you, you can always go to this channel and say, hey, I just want to learn this performance metric in regression in 5 6 minutes. You are good to go. Naive Bayes and central limit theorem, these kind of things, you are good to go in a short span of time for a quick revision. So I have provided you everything that you need on this GitHub page. Every link is there regarding the ML interview questions, your YouTube videos if you want, and the interview question concepts that I explain here. And this is my email ID, and you can always ask me on this thing. So yes, Mansi is asking, deadline of project submission is 10th. So yes, 10th is the deadline, actually, Mansi, but timing I am not aware of. Like it's 11:59, or maybe Chavi can comment it out. So I'll ask, and from Chavi, like what's the deadline? So let me go to Risk 11 Marathon. So maybe here. Okay, so that was I think regarding to your profile only, I think. So I think you are connected with us on WhatsApp for in the WhatsApp group, or in the that group. So Chavi will reach out to you, like the deadline is 11:59 or something else. So yeah. Anything else, guys? Gurpreet, Harish, Suraj, Pooja, Mansi. Anything else? If you want to ask any question, please feel free to ask me. So, is it necessary to submit final prediction in a yes no format or in a 0 1 format? No, no, you have to do in yes or no format only, because whatever the training data is looking like, Himanshu, you have to do in that format only. So yeah, 0 and 1 format you will be doing internally to train your models, because machine learning models understand numbers only. But for us to judge and make the word, I mean, easy for us, so please submit in yes or no format. Yeah, you can basically predict, and you can simply do 0 and 1, like 0 for no and 1 for yes. Any other question? Yeah, I am looking at your comments, waiting for your comments. Yeah, thank you, Gurpreet. Yeah, thank you, Mansi. Yeah, thank you, everyone. So I hope nobody has any more questions. So feel free to reach out to me on these links. And if you have any doubts regarding ML interviews or anything, uh, you can always, and if you need any help in the project or any kind of thing, if I can guide you, I'll be happy to help you. Okay, so Himanshu is asking, a model with high accuracy implies overfitting. So overfitting basically means your model is performing good on the training data set. So when you are doing a train test split, okay, so when you are doing a train test split, so your model is performing well on the training data set, but when or I mean the validation data sets, but when you are doing this on the real data sets, live data sets, okay, your model will not perform good, so it will be um, I mean high bias. Okay. So a model with higher accuracy implies overfitting. Did you get it now, Himanshu? So overfitting is basically a concept where your model is performing good on the, I mean, training, it's performing very good, but in testing in real, it is not performing well. So accuracy does mean like true positive plus true negative. Even if out of true positive and true negative, one of them is lower, okay, you say, okay, my model is good in predicting all the person having a heart disease only, then also your accuracy will be higher. Why? Because true positive plus true negative, either of one can be zero also, but then also you'll be getting 90% accuracy, okay. But um, in the precision and recall you don't have these kind. So in case of imbalance data set that I also explained during this, in case of an imbalanced data set, you can also say uh, like accuracy will not be a good metric, because one class is very low and one class is very high, so it will not be good. Yeah. So one question is, the submission criteria is mentioned that we have to submit a result.csv. So yes, Pooja, in the result.csv, what I'm expecting from you is from the term deposit that you have to, I mean, predict. So that please save it as a CSV format for under the name of result.csv and share with us. So I'm interested in knowing only the one column for the predictions. Yeah, any other question? Okay, I think no more question is there. So thank you all for attending this event and making this event a successful one for the past 2 days. And I wish you all the best for your, I mean, the challenge. So I mean, keep it as a learning kind of thing. So I believe that participation is more important than winning. So keep on, I mean, improving, and please see the project, the hands-on project that we did, and see like what have we followed, the from each graph how I extracted information. The same strategy you can also follow. And that's all from me now, and I'll be looking forward to your submissions and different kind of solutions that you're going to submit to me, and the answer to the ML questions. So the answer to the ML questions will be um, good to go with after learning the concepts from today, because it explained everything. So looking forward to your solutions, and deciding the best you. Yeah. Yes, Pooja. So I was saying, like you have been given a testing data set, and you have to predict the values for it. Okay, you have to predict the values, like the term deposit for it. So when you are doing the predictions, just save it as a CSV. So there is a one function that is df dot two underscore CSV. Okay, in Python, if you search two underscore CSV is a function that will, I mean, change your data frame to a CSV, and just save it as and pass the path like .csv result .csv. So your data frame will be saved as CSV. So I'm interested in knowing your that results file. I hope it's clear now. So I thank you all for attending, and looking forward to your submissions. I hope it's clear. So that's all from my side. So Chavi will end the session, and I mean, thank you. Bye, everyone.
Okay, so I hope that all of you got a proper knowledge that how you can get start your um, machine learning journey today.
Yeah, I think her network is slow. So I hope you enjoyed, everyone enjoyed the ML marathon, and I thank you all from me and Chavi side. So thank you everyone, and bye, and have a nice day. And that's all from my side. Thank you.